So this video is a little bit more on trigonometry related to finding missing angles and missing sides in right angle triangles. So you might remember this acronym Sohcahtoa that you used in high school. So we'll look at first right triangles. So this Sohcahtoa only works for right triangles. So let's name the sides of the triangle. So the side that's across from the right angle in the right angle triangle is always called the hypotenuse. So that is H. Okay, and then my opposite and adjacent sides are depending on where my focus angle is. So say if I place my focus angle here, then the side opposite to that angle is going to be this one over here. So this would be the opposite side. And then the side that's touching it would be the adjacent side. Okay, just be careful too, I can orient my right angle triangle however I want, so I could spin it like this. So now let's say I have my focus angle is up here, or down here I guess, and I want to name my sides. So my hypotenuse is always the side that's across from the right angle, so that's going to be this side here. My opposite side then, based on my focus angle where theta is, that's going to be this one here, and then my adjacent side is this one here. Okay, so, and then the acronym Sohcahtoa, just so you remember, what it means is sine of your angle is equal to the opposite side divided by the hypotenuse, so the opposite side related to theta. Cos of theta is equal to your adjacent side to theta over your hypotenuse, and tan of theta is equal to the opposite side to theta over the adjacent side to theta. Okay, so let's look at some examples. Okay, so my first example here, let's say I have a focus angle here of 30 degrees, and this side is 5. Now I want to solve for the other two missing sides, so let's call this side H because it's the hypotenuse, and we'll call this side here X. So if I solve first for H, what I can do is I have to use the information that's given to me, so the 30-degree angle and the side that's 5. So I'm trying to solve for H here. So I have the opposite side to the 30-degree angle, because it's opposite 30 degrees, and I have the hypotenuse. So opposite and hypotenuse was sine. So I have the relationship sine of 30 degrees is going to be equal to opposite over the hypotenuse. Okay, and then when you're trying to solve for a denominator of a fraction, what you're going to do is multiply both sides by h and then divide both sides by sine 30, or you can just use a quick trick then of you're just going to switch their places here. So we're going to get h is equal to 5 divided by sine of 30. So when you plug that into your calculator, 5 divided by sine 30 is going to give you a nice even 10. So I have here that the hypotenuse is 10. Okay, and then same idea to solve for side x. So now I'm going to erase this so I have some room. So looking at the 30-degree angle, x is the adjacent side and I have the opposite. So don't use what you've solved for. So don't use this 10 that you just solved for. Use the 5 and the x and the 30 to solve for x. So I have opposite and adjacent. So opposite and adjacent was tan. So tan of 30 degrees is going to be equal to opposite over adjacent. So it looks like that. And again, I'm trying to solve for that number in my denominator, so I can just switch x and tan 30 to solve for x. So I get x is equal to 5 over tan 30. And if I plug that into my calculator, I get rounded to 2 decimal places 8.66. So I get x is approximately 8.66. And if you wanted to check this using Pythagorean theorem to make sure that 8.66 squared plus 5 squared is approximately 10 squared, then you'll know that you got the answers correct. So I did round this one here, so it won't be exact. Okay, let's look at another quick couple examples here. So if I have, let's say this side is 12, and then I have an angle here of 60 degrees, and I want to solve for my missing side. So I want to solve, let's call this side x and this side y. Okay, so to solve for x, I have x is opposite to 60 degrees because it's across from the 60-degree angle. So I have opposite and I have the hypotenuse. So opposite and hypotenuse is sine. So I have sine of 60 is equal to opposite over hypotenuse. Okay, and then to solve for x, now what I do is I just multiply both sides by 12 and by 12. So I get x is equal to 12 sine of 60. So x, once you plug that into your calculator, you'll get rounded to 2 decimal places that it's about 10.39. So I get x is 10.39. And then doing the same thing to solve for y. So y is the adjacent side to 60 degrees, and then I have the hypotenuse. So again, don't use what you've solved for. So I have adjacent and hypotenuse, so that is cos. So cos of 60 degrees is equal to the adjacent side over the hypotenuse. And same kind of thing that I did for the last one, multiply both sides by 12. So I get y is equal to 12 times cos of 60 degrees. So once you plug that into your calculator, you'll get that it's a nice even 6. So y is equal to 6 units there. And again, if you want to check it using Pythagorean theorem, you can do that. Another quick check too is that your hypotenuse should always be the longest side in your triangle as well. Okay, so let's look at some examples for solving for missing angles. So let's say in this first triangle here, I'm given two sides. So I have this side is 5 and this side is 8. And I want to figure out what is the measure of this angle here. So again, I can use Sohcahtoa. So related to this angle, I have the adjacent side and then I have the hypotenuse. So adjacent and hypotenuse is going to be cos. So I know I have cos of theta is equal to your adjacent over hypotenuse, so 5 over 8. And then to finish solving for theta, so what you do, because cos, like sine, cos, and tan, these are trig functions, you have to take the inverse of the function in order to solve for theta. So like you can't divide by cos. Sometimes I see some of these funny things happening. So on your calculator, you might see right above your cos button, you'll have a cos inverse button, and that's what you want to use. So to solve for theta, it's going to be the cos inverse of 5 over 8. And depending on how your calculator works, if it works forwards or backwards, you'll have to figure out how you plug that in. And rounded to 2 decimal places, you'll get that theta is approximately 51.32 degrees. So we were solving for an angle, so make sure you put degrees on there. Okay, if you wanted to solve for the other missing angle, you could do that. You know the angles in a triangle all add up to 180, so you could figure that out. You could also find this missing side here simply by using Pythagorean theorem if you wanted to do a squared plus b squared equals c squared. Okay, and then in this triangle, let's say I have this side is 2 and this side is 9, and I want to solve for this missing angle up here. So I have the opposite side to this angle, and then I have the hypotenuse. So I have opposite and hypotenuse, so I know that's sine. So I have sine of theta is equal to opposite over hypotenuse. So then to solve for theta, again, I have to use the inverse function, so sine inverse of 2 over 9. And then when I plug that into my calculator, I'll get that the angle in this triangle is rounded to 2 decimal places, approximately 12.84 degrees. Okay, and let's just see one quick word problem. Okay, so I have the top of a ladder is leaning against a building, and it reaches a point on the building which is 25 feet above the ground. If the base of the ladder is 7 feet from the building, we want to find what is the measure that the ladder makes with the level ground to the nearest degree. So let's draw ourselves a little picture. So I have the ground here, which they're telling me is level. Okay, and then I have a building here, let's say at the end. So here's my building with some windows and a door. And then I have a ladder leaning against the building. So let's draw on the ladder, which is, let's say here. Okay, so I want to figure out the angle that the ladder makes with the ground. So I'm looking for this angle here. And I know that this is a right angle, the ground with the building. And then I also know, they told me that the base of the ladder was 7 feet from the building. So I know that this is 7 feet from the base of the ladder to so from here to here. And then I know the height that the ladder reaches on the building was 25 feet. So I see I have a triangle with two sides, the base being 7 and the height being 25, and I'm looking for this angle right in here. So to figure that out, I have the opposite side to the angle and I have the adjacent side to the angle, so it's going to be opposite over adjacent, so it's tan. So I have tan theta is equal to opposite over adjacent. So again, to solve for an angle, I have to use the inverse trig function. So tan inverse is, or theta is equal to tan inverse of 25 over 7. And then when I plug that into my calculator, I get that theta is approximately 74.36 degrees, and they wanted it to the nearest degree, so theta is approximately 74 degrees. Okay, so that's it. Thanks for watching. Good luck with the assignments.